Could humans one day traverse the vast expanse between stars, exploring new worlds and perhaps even civilizations beyond our solar system? A question that has fueled countless dreams and ignited the fires of imagination. Interstellar travel, the concept of journeying to the stars, is an idea that seems as vast and challenging as the cosmos itself. Just to give you a sense of the scale, consider this. Even our closest neighbor, Proxima Centauri, is a staggering 4 light-years away. That's about 24 trillion miles, or to put it into perspective, it's equivalent to over 260,000 round trips to the moon. The sheer distances involved in interstellar travel present immense challenges, from the technological to the biological. We're talking about navigating cosmic oceans that make our earthly seas look like mere puddles. But don't let the enormity of the task dampen your spirits. It's evident that interstellar travel is an immense challenge, but let's delve into how far we've come in conquering space and the technological leaps we've made to date. From the first steps on the moon to rovers on Mars and probes venturing to the outer reaches of our solar system, we've come a long way in our space exploration journey. Our tale of space travel begins with the early rockets. In the mid-20th century, these primitive yet revolutionary machines propelled us into a new era, an era where the sky was no longer the limit. Rockets like the Saturn V, the behemoth that carried humans to the moon, were a testament to human ingenuity and determination. Then came the Apollo missions. Who could forget the famous words of Neil Armstrong in 1969 as he stepped onto the lunar surface? "That's one small step for man, one giant leap for mankind." The moon landing was more than a triumph of technology. It was a symbol of human ambition and a beacon of hope in a world divided. As the decades rolled on, the Space Shuttle program was born. These reusable spacecrafts, like trusty steeds, carried astronauts and supplies to and from the International Space Station. The shuttles were a marvel of engineering, opening up a world of possibilities for scientific research and international cooperation in space. In the new millennium, unmanned missions to Mars and beyond have become the new frontier. Rovers like Spirit, Opportunity, and Curiosity roam the Martian landscape, while probes like Voyager and New Horizons venture to the outer edges of our solar system and beyond. These missions are our eyes and ears in the cosmos, revealing a universe of wonders right at our fingertips. But none of this would be possible without advancements in technology. Propulsion technology has evolved from chemical rockets to ion drives and nuclear propulsion, allowing us to travel faster and further. Spacecraft design has become more sophisticated with improvements in materials, systems, and instruments. Life support systems have also advanced, with better recycling systems and potential for growing food in space. With each mission, we've pushed the boundaries further, bringing the dream of interstellar travel a bit closer to reality. As we stand on the cusp of a new era, we are developing technologies that could potentially take us to the stars. The vast expanse of space is a daunting challenge, but human ingenuity and curiosity are limitless. Let's talk about some of the concepts and technologies that could make interstellar travel possible. The first concept is that of generation ships, colossal spacecraft capable of supporting human life for centuries. These ships could serve as a mobile home for several generations of astronauts, allowing humanity to travel vast distances over centuries. Next on the list is the concept of warp drives, a speculative technology that could allow us to bend the fabric of space-time. Imagine folding a piece of paper to bring two distant points closer together. That's what a warp drive could theoretically do. It's a concept that's straight out of science fiction, and while we're not quite there yet, research is ongoing. However, long-distance space travel isn't just about propulsion and spacecraft design. The human body wasn't designed for space, and the biological impacts of long-duration space travel are a significant concern. From muscle atrophy and bone density loss to radiation exposure and psychological effects, there's a lot we need to understand and mitigate. To this end, scientists are conducting extensive research. They're studying the effects of microgravity on the human body and developing countermeasures. They're looking into advanced radiation shielding techniques and exploring the psychological support needed for long-duration space missions. But perhaps the most exciting research is in the field of suspended animation or hibernation. This is the idea of slowing down human metabolism and bodily functions, allowing astronauts to sleep through the long journey. It's a concept that could solve many of the challenges of interstellar travel. Interstellar travel remains a dream for now, but every day we inch closer to making that dream a reality. Perhaps one day we will indeed reach the stars.